Hi, everyone, and welcome back to Research Unraveled. I'm your host, Alex, and today we're diving into a fascinating intersection of artificial intelligence in the stock market. We have Sarah, an expert in both finance and AI, joining us to break down a recent research paper on using something called xLSTM networks for automated stock trading. Sarah, welcome to the show.
Thanks for having me, Alex. I'm excited to be here.
So let's jump right in. The paper is titled A Deep Reinforcement Learning Approach to Automated Stock Trading Using xLSTM Networks. That sounds pretty technical. Can you give us the elevator pitch version?
Sure, basically, the researchers were trying to build a better automated stock trading system. They used a type of AI called deep reinforcement learning, which is like teaching a computer to play a game. The game here is the stock market, and instead of using the standard type of neural network, they used a newer, more advanced one called an xLSTM network. The idea is that xLSTMs can handle the complexities of the stock market better than older models.
Okay, deep reinforcement learning, I've definitely heard about that. It's like training an AI agent to make decisions based on rewards, right? But what's so special about xLSTM? You mentioned it's more advanced than standard neural networks.
Exactly, deep reinforcement learning, DRL, is a powerful approach where an agent learns to make decisions in an environment to maximize a cumulative reward. In the context of stock trading, the agent observes market data, like stock prices and trading volumes, takes actions like buying, selling, or holding stocks, and receives rewards, profit or loss. The goal is to learn a trading strategy that maximizes long-term profits. Now, understand XLSTM, we need to talk a little bit about LSTMs first. LSTM stands for long short-term memory. They are a type of recurrent neural network, RNN, specifically designed to handle sequential data. Think of them as having a memory that allows them to remember past information and use it to make better predictions. This is crucial for stock trading because past stock prices and market trends can influence future prices. However, traditional LSTMs have limitations. They can struggle with very long sequences of data, and they can sometimes have trouble capturing long-term dependencies, meaning they might forget information from a long time ago. This is where xLSTM comes in. xLSTM, or Extended LSTM, is a newer architecture designed to address these limitations. It's like a buffed-up version of the LSTM.
So what are the key differences between LSTM and xLSTM?
There are a couple of key innovations in xLSTM. The paper mentions two main components, SLSTM and MLSTM blocks. Think of them as different types of memory cells within the network. SLSTM uses scalar memory and a novel memory mixing mechanism, while MLSTM is designed for parallel processing using matrix memory and covariance updates. This allows xLSTM to process information more efficiently and retain long-term dependencies better than standard LSTMs. It is also designed to mitigate the gradient vanishing problem, which is a common issue in RNNs that can hinder learning long-term patterns.
Okay, that makes sense. So the researchers used this xLSTM network within a deep reinforcement learning framework to build their automated trading system. How exactly did they do that?
They used a specific reinforcement learning algorithm called proximal policy optimization, or PPO. PPO is a popular algorithm because it's relatively stable and efficient. It tries to find the best trading strategy by balancing exploration, trying new things, and exploitation, sticking with what works. In their setup, they used two xLSTM networks, one for the actor and one for the critic. The actor is responsible for making the trading decisions, deciding when to buy, sell, or hold. The critic evaluates the actor's decisions, essentially telling it how good or bad its actions were. This feedback helps the actor learn and improve its trading strategy over time.
So the actor is the trader and the critic is the financial advisor.
That's a great analogy. The actor tries to maximize its profits, and the critic helps it understand what actions lead to those profits.
What data did they use to train and test their system?
They used historical stock market data from five major tech companies: NVIDIA, Apple, Microsoft, Google, and Amazon. They used data from 2009 to 2022 for training and then tested the system on data from 2022 to 2024. This allowed them to see how well the system performed on unseen data.
And what were the results? Did the xLSTM-based system actually outperform traditional LSTM-based systems?
Yes, it did. The paper reports that the xLSTM based model outperformed the LSTM based model in several key trading evaluation metrics.
What kind of metrics are we talking about?
They looked at things like cumulative return, which is the total return on the portfolio after the trading period. The xLSTM model achieved a higher cumulative return, meaning it made more profit overall. Maximum pullback, which measures the maximum percentage decrease in profitability. The xLSTM model had a lower maximum pullback, indicating it was less prone to significant losses. Sharp ratio, which is a risk-adjusted return measure. A higher Sharp ratio indicates a better return for the level of risk taken. The xLSTM model had a significantly higher Sharp ratio, suggesting it was a more efficient and less risky trading strategy. The results from the paper clearly shows that the xLSTM model, with a time window of 30, outperformed the base LSTM model across all these metrics. For example, the xLSTM model achieved a cumulative return of 53.11 compared to 46.16 for the base LSTM model, and a Sharp ratio of 1.650 compared to 0.799 for the base LSTM model. The xLSTM model also had a significantly lower maximum pullback of 7.58 compared to 28.92 for the base LSTM model, indicating a more stable and less risky trading strategy.
Wow, those are some impressive results. So it seems like xLSTM really does offer an advantage in this context. Were there any limitations to the study?
Yes, there were a few. The researchers acknowledged that training xLSTM networks requires more computational resources, which limited the scale of their experiments. They also focused on a relatively small set of stocks and features. In the future, it would be interesting to see how xLSTM performs with a larger dataset and more complex features.
What are some potential avenues for future research in this area?
The researchers suggest a few interesting directions. One is to explore more powerful feature engineering techniques to provide the model with even more relevant information. Another is to use ensemble modeling, which involves combining multiple xLSTM networks to improve performance and robustness.
So what's the big takeaway here? Is xLSTM the future of automated stock trading?
It's definitely a promising development. This study provides strong evidence that xLSTM networks can enhance DRL-based stock trading systems. While it's not a magic bullet, it's a significant step forward in building more sophisticated and effective AI-powered trading tools. It shows that xLSTM networks can effectively address many LSTM limitations and opens up new possibilities for processing time series data in financial markets.
Sarah, this has been incredibly insightful. Thank you for breaking down this complex research paper for us.
My pleasure, Alex. Thanks for having me.
And that's all the time we have for today's episode of Research Unraveled. Join us next time for another deep dive into the exciting world of technology.